Okay. So the last this is the discussion, right? The last discussion today is going to be about like an open floor situation where what we want to know about is there something that would make or break EESSI for your sites, or is there something that you can already see that is a restriction for you that will not allow you to use EESSI or will make it using EESSI hard at your site? So that's the question.
Very easy one on relative short term. That's commercial compilers, Intel, for example. Yeah, example. And the second one on longer term is commercial software. So it is not that it will break our usage of PC in the sense that we won't use it. It's more that it won't be enough.
So if I kind of make a response to that, I would say, yeah, we understand the situation, right? And so, I mean, the first block that we've come up against is the NVIDIA, right? The CUDA compiler. I think we have a solution for that. In terms of like the Intel compiler, it's a similar situation. I think you are allowed to chip the runtime, right? So if we take the same approach, that should be a solvable problem. First thing we want to do is check is that the approach actually works in practice, right? So at the moment it's like a concept, and we have a working from just our discussions the other day. We'll probably change a little tiny bit how we do things, but I believe it should work, right? We already had something that worked. This will just work a little bit better, and so the same would be true for commercial compilers. But there's a difference, right? So the thing with the commercial compiler situation is that we have to. It's not just about shipping it with EESSI. Do you want software built with that compiler inside? That's another issue because there may not be a tool chain for that, right? So already we have that as a situation with AMD or something like that. Or what are we going to do as regards their compiler, their client compiler? Is it better? That's an open question, right? So a lot of the development in that AMD has done on the client compiler is already upstream, so it's not necessarily better to use the AMD compiler. Of course, that probably depends, right? And it depends how fast these things move. And there may be points in time where one is better than the other, and that may change 6 months down the road. So, of course, these things are a moving target. And of course, if you talk about that approach, supporting a compiler is a big deal, right? Because who do we say we support? All of the software we support everywhere else, we also support it with that compiler. That's possible, but that involves significant workload. What was the other? The second one was. Yeah. I mean, Bart is on the call. I think I thought I saw him. He was here for the picture at least. And I know that they have a tool that looks inside the binaries, right, and changes the linker, right, for these kind of things, so that it finds Gentoo prefix libraries. That's probably something, but it's probably not enough.
For ISV software, it's not just the technical issue of getting it to work. It's also, unless we have explicit permission from MathWorks, for example, to include MATLAB in EESSI, it's not going to come through there, and you need to take matters into your own hands and set up your own repo for that type of software. And we're never going to be allowed to ship all possible software. I'm thinking like Fluent and all these things. Then I don't see that happening. So, and like Danilo also said, there's always going to be situations where you want your own stuff anyway, for a variety of reasons. But that's definitely something we'll always have. We can try to reach out to MathWorks and ANSYS, and if we do that through Azure, maybe they will listen. But listening and actually giving us permission, that's a whole. We can engage that discussion and just see what comes out of it. And anyway, regardless of how the discussion turns out, we will always need a way to also build stuff on top or install stuff on the side and make sure it can work together well with what we provide.
To that end, my take on this is it would be an absolute kicker if if you couldn't easily extend or overwrite bits of EESSI, if it was built in a way so that you could not add elements or override elements or stuff, it had to be this and this only, that would be like, no, sorry, I have to go and do something else, because there's always going to be something that isn't quite right or something that wants modification.
There is kind of a somewhat of a restriction there, in the sense that you can shadow anything that's in EESSI, right? But you have to remember that inside EESSI, everything is RPath. Even if you shadow a module, that anything inside EESSI will actually pick. I mean, direct, if you use direct usage, yeah, fine. But if you, because you have a module, the libraries from that, which is fine. I mean, like you know, there are ways around this, right? So if you something a writable layer on top where you allow yourself to write into these applications, there are ways you can.
My 2 cents. If it was set up that way that it was like you couldn't, then that would be.
I mean, the way that we do, we have an easy build in common layer. All the other software that is in the upper layer is built with easy build using our. We have this cross compatibility along up in the. People want to install something, install with easy build, the proper configuration. It should be compatible.
It's kind of a nice way to like prepare something so that it. So you build that you've got it kind of locally, and that gives the set up so you can build stuff through the development back. And eventually, you kind of don't want to have to do this, but it's kind of useful to have it so that you can quickly locally hack them.
For a developer, that's exactly what you would want to do, right? So you'd want to use all the tooling or all the things that are inside EESSI and try your own application out. It's kind of the same approach. Okay, you're actually using EasyBuild itself, right? But that's not necessarily the case, right? You might be just using CMake or whatever build process, and you could do that. So the same CI setup would work both. But it is interesting to talk about that separation between testing and production. Like, so in production, we have the full stack, right? But what about when we want to start working on a new compiler or something like that? What happens at that point? Release that immediately somewhere else so that people can use that straight away in CI? Or do we hold everything back until everything is ready and then talk about owning production only? There are a couple of approaches there. I thought somebody wanted to talk a little bit in Zoom. I thought I heard somebody say something. Bart, your hand is up actually, yeah.
Yeah, and I'm just giving a few comments about the ISV software. You certainly can't put them in a public repo. What we do with Compute Canada is that we have a restricted.computecanada.ca CVMFS repository where people need a special key to mount it, otherwise it's not accessible. Because there's some, and even in there's some parts that have a special GID. So actually, you need to be a member of a certain group to be able to read that software. And then, so that's one other reason why we need a special key, because we want to have control over the GIDs and IDs to make it accessible to exactly the right users. But even with that restricted repository, there's still one piece of software, VASP, that doesn't that we can't even install there because they don't want it installed Canada-wide. They only allow one institution to sign an agreement with VASP and then install it on the cluster. And there's something similar with the Mathematica license. You can't install it in some distributed file system, no matter what you do. So, but with the host injections, you have a lot of flexibility to install the proprietary. Yeah, I mean, we could even use host injection and then put in a symbolic link to restricted repository, and that will work as well. As for the compilers, yeah, I mean, if you look at Agner Fogg, who knows a thing or two about compiler optimization, he's pretty adamant that it's like basically we're working towards a duopoly of compilers. It's either a GCC or Clang or anything else LLVM based. Like pretty much all the proprietary compilers have moved to LLVM. The AMD compiler is LLVM based. NVA PC is LLVM. Intel is now LLVM. They just have their own little optimizations. The main thing for Intel is that they just have more aggressive floating point optimizations by default. And so for C++, the difference are getting smaller and smaller, I think. For Fortran, it's still a different story. I say some of the proprietary have some leeway on the Fortran front. So I do keep an eye on but and rate tool change. I don't know.
We lost you for a second, Bart, so we probably missed the last sentence or so.
Yeah, I just think for the easy build, there's always been too big tool chain, but the Clang has been a bit of a second-rate citizen. The build thing, it needs better supported.
Yeah,
I think it's mostly also a question of Fortran.
Yeah. So for me, what I was looking at in the last 6 months, or what I was trying to work towards, was something like a Clang-based tool chain with this this intermediate MPI layer, right? This MPI trampoline, something that would allow you to switch out to whatever MPI implementation you wanted, and because that's something that I can imagine being important for some sites, right? Being able to use their vendor-provided MPI in a relatively straightforward way, and that's not easy to do. I mean, it's not easy to make that swap out right now. You have ABI compatibility, but that's actually not that easy to get working correctly in practice, at least in my experience.
Yeah, so I think for us, to bring in a different point, I think for us availability would be an important point, right? So I know that we have sysadmins that are very reluctant to place anything outside of the system at all. They're like, okay, even if the network connection to the rest of Surf goes down, we want the cluster to be able to continue doing its work. So yeah, for us, it would be the ability to place probably a private Stratum 1 within the same cluster, and then that way guaranteeing always availability.
One more thing I wanted to say about the R pathing is, well, there may be some promise in that Harman Stoppel's idea of setting the SO name to an absolute path in the shared libraries. So
yeah,
he's not a Nix, but anyway.
We talked about.
Yeah.
We talked about this the other day a little bit, because I think that's also very interesting, because the reality of our path right now is it tells the places to search, right? So
yeah.
So if some software comes along with the same library names as something else, and it depends where it appears in the dependency tree, you can still make a mistake, right? You can still pick up a library from a wrong location. Okay, it won't even have the symbols that you want probably, but that can happen. Whereas with this fixed path situation, you get something that really is quite static, right? And you remove all that searching.
Exactly. It saves a lot when you look at strays for any piece of software that has either you have a long LD library path or a long R path. The list of locations is very long. It doesn't just look in the locations, but also looks in subdirectories of those locations of various architecture dependent directories. So like the searching can really take a significant amount of time and kind of eliminate that. That's the second benefit. The only thing I'm sometimes worrying about with proprietary software is that the patching of it may not be legally allowed, because basically license says no modification whatsoever is allowed. So if you do patch elf for proprietary application, you basically change the software. You don't functionally change it, but you do modifications. So technically, it's forbidden. In the sense that the SHA-256 different, of course. Of course, everything. I think everything in computer science can be redirected using kind of intermediate layer.
You can have a
using
wrapper that
redirection from.
yeah.
Yeah, you can always do a wrapper around the wrapper around the wrapper and solve any issue in computer science.
But for the availability thing, Caspar, I mean, isn't that fully mitigated by having your own Stratum 1? Because then you have a full mirror and you can even disconnect yourself from the internet. And I mean, you're not going to pick up new stuff, but it's not going to bring your cluster now. Yeah, that's something I think we'll have to explain very well to people. Like if you want to be secure or you want to be self-resilient, right? Protect yourself against trouble upstream. Yeah, you really need a full mirror. And the only thing is then you're still losing control. And that's something that we saw in the easy build community. Many people were reluctant to start using easy build because they felt they were losing control. Like we don't control how OpenFOAM is being built anymore. And maybe we can. I mean, it's all open source. We can spend 3 weeks figuring it out and what we need to tune, but we don't want to make that effort, right? We rather use a bash script that does it instead. In some sense, easy is worse, right? I mean, you can still shadow stuff, but if something is in there, you can make some effort in hiding it. Certainly the modules you can hide, but still in there, right? And if you don't want that for whatever reason, yeah. That's maybe also something we'll have to be careful with, or at least listen to any feedback we get there from people who are considering or are not considering easy because of this. Also try to trigger people to actually come up and tell it to us. Problem.
Regarding stability and stuff like that, keep in mind that most of the users on your systems already use OHC for Atlas and so it's already there.
About Kenneth's point there, actually, can you use your CVMFS config to exclude locations? And the other one I was wondering about is the cache lifetime. So if you get disconnected, right, from Stratum whatever, Stratum 0, right, and you have a Stratum 1, does the information in your Stratum 1 have a lifetime in terms of your cache or something like that?
That's why the whitelist signing thing relevant. I think. I'm not sure if CVMFS will still trust your Stratum 1 if it notices that the whitelist hasn't been signed or something like this. I mean, so the whitelist is on Stratum 0, the Stratum 1 picks it up somehow. If you like disconnect for a week, I'm not sure what's going to happen. That's maybe a question we should raise to. Yeah, we can either it's documented or we can ask them what would happen in this theoretical scenario. And maybe it's not theoretical at all. If you want to, you're in a system where called air gapped, so you don't allow any connection to the outside world. Maybe you only want to sync once a week with upstream easy. Is that feasible, or is that or do we have to reconfigure something so it is feasible? Like we could resign the whitelist only once a month. Yeah, but that's definitely a factor too.
I was going to say, if you're encouraging Stratum 1 for HPC sites, you've also got all of the keys and firewall configuration for Stratum 0 requiring 2 QB keys. There's going to be a lot of visits to the data center. Be interesting. One of the, from my perspective, one of the big benefits is not only having stuff built, but having it so that it's actually tested properly, ideally, so that then you have a bit more faith as an administrator, as a user, that what you're working with actually does what it's supposed to do, does what it's supposed to do reliably, hypothetically does it also for years to come as well. And that's one of the big benefits I can see. Although how dealing with previous versions, think about that. You're doing deduplication, and a lot of data is the same between versions. Is tarballing necessarily the most elegant solution? Not just put the old one, of the old data on the version. If it's very little difference between them. Yeah, I know. That's why I'm saying maybe tarballs aren't the most elegant solution for archival stuff.
Yeah, that's probably true, but here, I suppose. If it's just the archival process.
I don't know about that. I still have users that use the leg like Python 2 stuff.
You
right?
can do it. So instead of taking a tarball patch, you could take an alien cache. Entire thing. Probably, I assume, already has that deduplication inside. So that's likely to be a lot smaller
That'd
than
be site specific. Then
an alien cache.
Yeah.
No,
So
you could just say anything under this repository.
Yeah.
I want an alien cache. I want an entire copy. That probably has it does have the deduplication.
But I mean, as in, so from a project perspective, you versions, historical components going on. How long can those stay around for? How big can it get? How big is the entire thing willing to get over time? How long a history is valid for you?
Well, I mean, maybe Bart, it's interesting for you to come in at this point and say, like, you guys have been doing this for like 5 years or more, or whatever it is. How big have things gotten in your experience?
I think, if I remember, there was a talk by Ryan Taylor at the CVMFS meeting a couple of days ago, where he had some statistics on the size of our repository, quite a bit.
I think Kenneth is bringing it up here if he can.
Yeah. Yeah, there's a PDF, so Kenneth's doing the same work as I would be. Yeah, that's it. If you go scroll a bit lower, you'll see it on 1200 gigabytes. 2020.
And how much of that is current application? And how much is archived stuff?
Yeah, that's a good question. There's a lot of it that's no longer in active use. Like we have the whole Nix-based stack that is still there, and people can still use it, but of course it's getting fewer and fewer usage. But like in Jülich, they have these stages of older software stacks, and there's the occasional user that still needs to use the older software. So we keep it there because there's not much to lose. And in terms of like general storage, 1.2 terabytes it's not a lot anymore. If you have petabytes of Lustre storage, then what is 1.2 terabytes?
So at least we're not beating Moore's law then. That's convenient.
Yeah, no. It's a linear curve more or less. And you see, for instance, this is probably including the restricted repository. Like every time we install a new version of MATLAB on the restricted repository, we add over 600,000 files. So MATLAB is like an enormous inode consumer on this system. So just that is just for MATLAB, we need to set up several catalogs.
Surely that can't just be for MATLAB. There are other applications.
Yeah, no, there are other very
things
large
like this.
users. Like you, if you, I haven't done the analysis, but you will see that the general compiled software, the stuff compiled with EasyBuild and the Gen 2 stack, that doesn't take a lot of space. Then you have the odd outlier. We even have like a data repository for some bioinformatics stuff. The data stuff that takes enormous amount of storage. I can't remember which one it was, but there is one where we actually have a split between the actual software and the data sets because the data set is too large. I think that was it discussed on EasyBuild not so long ago as well.
Probably Interpro scan. but it needs data, and you just want to be able to install that data somewhere else. We split it up in two parts. Yeah. A very big data set that, if you're not careful, is just going straight along with your software, which is not a good idea.
Yes, exactly. It's inter-pro scan, and we have to split that. That was getting ridiculous.
No one else is picking up stuff, then I'll continue waffling on. That probably has an impact on things like testing. So if data sets are thousands of files, then having to deal with having a test data set that is significantly larger than the whole compilation, like source code and compiled binary, then also having to deal with that one as well in order to make sure that it tests properly, that could be kind of problematic over years.
I had this question before about your cache, the cache size of your client, and if data was being served through CWFS, can you like crash your cache, right, with some data? Right? Like if you've only got I don't know, 10 gigabytes or whatever of cache, and then you try and start using data sets that are 30 gigabytes, what happens?
Who knows this? Can you have a separate cache per repository or something? And that's a reason why you could have a data repository next to your software repository. I'm not sure how much control you get over cache. Can you?
I don't know.
Can you configure?
Yeah, I don't know either. That's a question for Ryan. You
Yeah.
should ask him.
Or Ryan or Jakob or.
Yeah.
Because yeah, that's indeed an important point. You're pulling in gigabytes of data, and that's all being pulled into your cache. It's going to destroy your startup.
We're having discussion that I do remember that he having a some data set cache extremely low because these are typical large files anyway. Anyhow, that you there. It's they EVMFS team will know for sure because they are used to this.
I had maybe a question for people. Graphics. So if EC was your software solution, what about graphics? What about there are in Ulic, you have graphical access to whatever, right? Visualization, etc. That off the table here, or is EC also? Put the dog in here. EC also could be a solution for that. What do people think? I think it's possible because I know that Ulic does all its graphical stuff through EasyBuild, right? And it even has the configuration to pick up the GL libraries from the host as well dynamically. So it'll do dynamic things based on whether it has those GL libraries or not. I hope he doesn't pee in the plugs now or something. The dog in the room, sorry.
So, whoops. From a template from Sarah, I built two visual nodes on our new cluster, and well, the thing is that you need, of course, some driver support. CUDA media driver support is the main thing. With that, we also installed XFC desktop and C client. That's about it. The rest I could make it work. So if those components, like things like virtual GL, are in C, then see any. You need a kind of X driver nation layer or
if I can add like the for Compute Canada the compatibility layer a lot bigger, so we include actually a whole 2D X server like XVNC and all the X libraries and Mesa in the compatibility layer. But I mean, it could be in the software layer. It's not either will work. One thing that greatly simplifies the setup is with virtual-GL 3.0 and up can work directly on EGL, so you no longer need to run a 3D X server on the node. So we can have accelerated software on any node that has a TPU installed without having to run the 3D-X server on it. So that just makes things so much easier on the admin side.
Yeah, to me that sounds like the way this can work, right? The way that this could work.
Yeah.
But
Yeah,
then
I mean, before we had a couple of visualization nodes which were dedicated and were running 3D-X servers, and now I can just I can start a job that reserves a TPU, and I can run virtual-GL just on any node that has a TPU, and it works super fast.
So the one thing I was wondering there was about the driver side of things. So for CUDA we have the compatibility libraries, and that's like a get out of jail card for that. Is there any problem? Is there any minimum stuff we need for on the driver side for the OpenGL libraries?
Yeah, I don't know. The compatibility layer doesn't have the OpenGL, but so we rely on the host OpenGL libraries, even if we have compatibility.
So, but
I
haven't hit the.
I have never seen an issue with that. I mean, the EGL just sort of funks down into the host EGL libraries, which are provided by NVIDIA.
So I guess we just yeah. I mean, that's the way we'll probably go. We'll just assume it works until somebody tells us it doesn't.
Yeah.
Right? Okay.
Yeah, you just need to make sure that I mean, with ETL, there are some configuration files that it reads where find the host libraries. It's not super hard. You just make sure that it finds the files in the right places.
Yeah, and yeah, there'll be solutions to that we can figure out.
Yeah.
Just for clarification, virtual GL myself. Does that not mean that you then end up having to compile a version generic, CPU based version for CUDA?
No, it's actually, this is getting more simplified over the years. There used to be you used to have like different OpenGL libraries, and particularly things like PowerView. There's like different varieties that you need, but things are sort of getting more simplified with ETL.
Standardized, convenient.
Which was off screen, and then it can basically you have the API which is in the main library, and then it has runtime plugins depending on your actual hardware. So and the same thing with libgl that goes via GLVND, that basically at runtime decides which underlying library.
My concern, of course, is adding it to the possibility exponentially growing the size.
Yeah, no. What we do is that we have GLVND in the compatibility layer and also Mesa in there, but you can have both of them in the software layer. And then when you actually have NVIDIA hardware, then GLVND will use NVIDIA OpenGL instead of.
One other thing I think is important in terms of making or breaking easy is that we should make sure that the researchers are happy with what we're providing. We can shout from the rooftops like, this is better than containers, this is better than Conda. we want to make this a community thing, and then give them something they're unhappy with. So like one important aspect there is the module tree. Certainly in Ghent, we barely pay any attention to that at all. People send us an install request, we usually answer module load this, and you should be happy. If not, let us barely get complaints on this. I also don't know how often people run module avail on our system. If they do, I don't think they're very happy. That they're not getting a useful answer. So that aspect, that let's say user experience, is something we have to keep an eye out for, and probably actively go and probe teams or groups of people that and let them play with it and actually see how happy they are or how happy they aren't.
So that
We have some very happy users, and some that are technical enough to even mount it on their laptop. They are usually the happiest, but also every now and then there's like a scan done in home directories, and you wouldn't believe how many anacondas find. You can't control what people do in place.
So I mean, the one thing I did or I looked into in the past is that you would like to be able to build your own module tree, right, from the software that's inside EESSI, and you can to an extent, but unfortunately this module only aspect of EasyBuild is not perfect. There's lots of cases where it doesn't actually work, because people didn't take it into consideration when they wrote easy blocks and things like that. We're getting better at that, but there's a pretty big problematic one. I think it's Python package. I think you can't do module only on a Python package, so that's a pretty big problem. It's fixable, but so that's one thing. But also, I'm very aware that we control the view of the software for everybody now, right? So we actually have LMOD, right? So we control exactly how they look at software, and we could probably do a lot to improve that user experience. Given that in the EasyBuild case, we deliberately support multiple module tools. People could be using multiple module tools, but in our case, we actually control the view, how they can see the software, and we can build functionality based on that. And I think it's a lot of scope for doing clever plugins for LMOD, right? That could allow people to do things. I think we probably should ship a hierarchy as well as a flat naming scheme. But maybe do we even need to do that? Because we could write a plugin that just removes the I don't know. There are things that you could do, right? Clever things. Given that we have control over exactly how people see things, and probably do a lot in terms of plugins. And I think this idea that was discussed already about adding properties to software would be very powerful in that extent, right? Hidden elements in software that we can manipulate, right? And hide or view things based on what those properties are. And that would allow people, probably through just a simple LMOD RC file, to be able to do very powerful things in terms of how the software is actually presented.
We have a lot of cases. Well, I mean, every now and then the user asks for a very software that's not worth it install centrally. So sometimes we give a user an easy config, and then they just run EB with that easy config, and it gets installed in their home directory, and it works. I think my colleague Ali Karachi has even given a talk on that, like how you can kind of write their own easy config. Takes a bit of skill, but it's like moderate level skill where they will need to know the tool chain names, which regular user on our system they don't be aware of too.
You've actually got quite an interesting point there. So automate out not being able to see GPU stuff. Of course, on cluster, often the login nodes don't have GPUs, quite different to actual compute nodes. So if you make them not available, load them inside workers, want to know what they are. So there's got to be some way of having them viewable.
And so we discussed that too, right? Obviously, that would be the case. You might want to make them visible on the login nodes, right? Clearly, if your cluster supports these things, and you should be able to do that just with an environment variable. So instead of checking but he's just some sublabel, that should be allowed to override that, right? But whatever logic check is in there, you should have the ability to say, yeah, ignore the logic check and just do it.
Our site is, we have a quite different module structure that generally produces. So it's going to be, I'm anticipating 6 months if I use this an updated version of a module tree, rewrite all of their code, try to limit the damage. It's the sudden wave of breaking.
So, I mean, my belief on that front is that you should be able to rewrite, to do this module only on the entire stack. That should be possible for you to do, so you can have your own naming scheme and to present things however you want. But I also think that we should do such a good job on the default approach that maybe you won't want to do that after a while, right? Maybe you'll go, oh, come on, they get it like this everywhere else. Like, why are we doing something different?
In our case, I see view. Much. Does anyone else want to take over? You're talking.
Maybe another thing we need to hammer a bit and be a bit more vocal about is one of the key things we're doing is optimizing the installations hardware, making that transparent in some sense, so it's automatic. We should really highlight the impact of that, because there's so many people that just are either they're unaware or they're actively ignoring it and just assuming they're not really impacted from it. I saw that at the CERN VM workshop as well. I had a slide with the GROMACS graph, which was, I don't know, the second or third slide in my slide deck, and people were like, "Oh, okay, 60%. That's a bit much, right?" So maybe we should check on that as well, and people taking notes, and it's just a bit surprising to me that so many people are either not aware or choose to ignore it.
This is where the big sell from having tests and being able to show, look, use this, we can improve this by this much.
Yeah.
That's where the big benefit comes from. And
so
you do that through it.
Yeah, so maybe working towards, if we do have a good test suite and we do start collecting performance data, we should probably just deliberately run the wrong binaries on system and showing the impact and having like a public dashboard of that as well. So you can very easily point your colleague and say, look, if you're doing GROMACS like this, and you probably are if you do an RPM install, but with EESSI you're getting this, like, and the impact is that big. It's not going to be big for everything. And if it's not big, maybe it's a sign that we're overlooking something as well. Maybe the thing is silently being compiled with minus SSE4 or something as a hidden compiler option, and we just never noticed.
We can maybe tell you a war story about that a little bit. So when we were doing the paper last year for the EESSI paper, and in there you have the GROMACS example, right? Then we said, oh, maybe one piece of software is not enough. Maybe we should also show it for another piece of software. And we did it for Quantum Espresso. And it was faster generic than it was compiled for the hardware. And I mean, we couldn't include it. It wasn't a deliberate exclusion. It's just that we didn't have enough time, like, figure out why the hell that could be the case, right? But yeah, I mean, this is where measurement is key, right? So you think you think you're doing something good, and maybe you're not. And that's clearly could be a flaw of the EasyBuild build processes. And that's why you have to go a lot deeper, right, to figure that out. I don't know. I mean, it was an exclusion, right, that we had to do, but we just didn't have enough time to investigate, right? But I mean, then we said that the plan would be that we would follow up that paper with more software. That would be a paper that would include like lots of packages. We shouldn't think that.
I just want to apologize to the infra team for saying probably more public infrastructure, public visibility on things. Means yet more servers, yet more front ends.
I would like to say is that well, it's not upon us to, let's say, sell easy to our scientists, because in our case we have, of course, a first tier support team, which also does, let's say, consultancy directed towards researchers and students. And what we also see is that even if you have, let's say, optimized binaries, people just write scripts in a horrible way and use file systems as some kind of shared memory. But the problem is you can't really exactly tell from what the hell they are doing in Slurm, unless you actually confront them and say, well, sorry, but what you're doing is, I think, really wrong. And then you come up with a reply and say, well, sorry, this is how I've been told to do, and I have 3 weeks for my final report, and I'm doing it like this. And yeah, so not something you can really change, but you can actually go to, of course, the supervisor and say, and maybe we should talk in the future about how this is going to be done, how we can improve on this. So it's part of it is optimization. I totally agree, but the word needs to be get out to supporters of these faculty groups, and also they should be able to test things like AC and see, hey, I think this is better. I think I can sell this to our PhD. It's going to be a bit of a pickle.
I think one, I would hope that one big benefit of something like EESSI is collaboration between the people who actually use these stacks, and because there are places, universities, whether it's universities or whole countries, that are not the same level as other countries, right, in terms of their experience in the space, and it might offer them a gateway, right, to be able to ask questions that are like these kind of questions, like how do I figure out if they are doing something silly or something like that, in terms of this user support infrastructure, right, as well, that it's an opportunity to build a community where you can be quite open about these kind of things. And hopefully, if you don't have to spend so much time installing software, that you would have the time to actually do that, right? I mean, we see that already in EasyBuild, right? There's discussions on Slurm and quite a bit, right? And Slurm configuration and things like that, that people respond to, right, in quite great detail when necessary.
I had, well, maybe not a war story, but more of a user end thing. We recently had someone who was running AlphaFold in our GPU cluster, and he was complaining that the 72-hour wall clock limit was not enough for his jobs, which doesn't make sense, because we've never seen an AlphaFold run that runs for longer than 10 hours on the GPU. I was like, what the hell are you doing? Like, how big is your input? And he wasn't doing anything special, but it turned out he was actually running the CPU only version of AlphaFold on our GPUs. So he was allocating a GPU, but just not using it. And that's, I mean, to some extent, that's our fault, because that GPU module should not be available on our GPU cluster. But because of the CPU architecture being the same between our GPU cluster and non-GPU cluster, he was just loading the wrong module. So by loading the correct module, it was suddenly 10 times faster. And things like this, I'm sure, happen all the time, and you just overlook them. You never notice. So yeah, you cannot make everything automatic and always get the best possible results. There's still some education in users as well. And again, having a public dashboard where you say, if you're not hitting this or close to that, you're doing something very, very wrong, can maybe wake up a lot of people.
Yeah, we have monitoring in place for those kind of things. Just flagging down if GPUs are suspiciously underused. Same for CPU, like jobs that only use one CPU for when they serve the whole.
And you have monitoring in the sense that does that mean get alerts when jobs like this are being run?
Yeah, exactly. There's a dashboard that basically aggregates the information.
And that's something you actively follow up on, or only when it's really over the top?
Yeah, we do. Yeah, there's tickets. We have templates for tickets that we send to you.
I mean, that's clearly something people could share, because Ulick did the same thing, right? Ulick tracks the power usage on the node, right? Using the GPUs. So it's easy to see these. Well, there are ways, right? And then there are ways to interpret
you can detect
too.
this kind of stuff.
Yeah, I mean, this is similar thing like monitoring, like people abusing login nodes. That happens. Fine.
There we can just hard break it. That's what we do. We can do very, very strict memory limits on the nodes, and they open
Yeah, no, I mean,
open
we've got
tickets
C
because
groups.
Nextflow doesn't run. It needs more
Yeah.
than 4 gigs of memory to do anything.
Yeah, I mean, we have C groups on the login nodes now as well with CentOS. With CentOS 8, that's pretty easy to do. But even so, the people can use little memory, but a lot of CPU.
Yep.
For too long.
Do we have any other points to raise? We're slowly coming up on time, and we need to evacuate the building by 4. So, any last remarks?
So if this is being recorded, do we have a schedule for when things are going live?
Do we have a schedule for easy
Going live, going to
going
production.
production? Well,
I know we discussed it earlier on very
Yeah.
briefly, but
well, not a hard date, but so one of the goals in the multi-xscale project is, I think, six months into the project, you're supposed to have something that's production ready, reliable for the most common cluster architecture. So AMD, Intel, InfiniBand, probably NVIDIA GPUs, and we're fairly confident we can do that, maybe earlier even. So, and since there's now dedicated manpower thanks to multi-xscale, we're talking 4 or 5 pretty much full-time people that can focus their time on easy, rather than doing it on the side and spending 5% of your time on it. That's a very big difference. So now I think we can start, or well, I should put it the other way around. We will have to stop using the excuse that we don't have the manpower, because that's no longer true. So now we have to start delivering and actually show that we can do what we've been talking about. So let's say
summer next month.
Vague targets. So let's say summer 23. If we don't have something that's production ready on the most common HPC architectures, then at least we're doing something very wrong. I'm not going to make a hard claim it's going to be there and 100% stable if everyone in the world starts using it. So there's going to be growing pains for sure.
And there's still be scope for disappointment, right? So our promise there was a certain set of software, right? A limited set,
Yeah.
right? So how much will be in that layer at that time of production that's an open question.
The big things we have now, OpenFOAM, TensorFlow, those things should be there. TensorFlow with on top of GPUs is not that whole much different. So the bigger things, yeah, should be feasible, but yeah.
But I think what we'd like to have is the workflow in place to add stuff to that layer. And so certainly
So that bot aspect,
the door is open, right?
It's very important. Yeah. So that's I think a very important aspect. That's also one of the early goals in the project. That's one of the milestones we have to hit pretty early on, to have something like this and open it up to the community and then see how bad the floodgates are open. We don't really know.